So let's go ahead and start. So I'm going to weigh out 5.83 grams or close to it. We'll see how close I get of the table salt. And I'm going to add 100 grams of water to it. Okay, so 5.83 grams of salt to 100 grams of water. So let's go ahead and do that. Okay, this is close enough. So please record this mass, 5.844 grams. I'm going to record it in my lab notebook. And I forgot to tell you that I also have two thermometers here. One to measure the temperature of the solution inside of this little test tube, and the other one would be to measure the temperature of the ice salt water bath. And you'll see that this one gets really cold and we can monitor the temperatures. So the two probes are monitoring temperatures right here on this computer screen, and when I collect the data I can actually look at the temperature time data graphically. So that's going to be my other equipment to use. So let's go ahead and raise this so we can get this ready. So I'm going to take my salt. I'm going to transfer it into an Erlenmeyer flask. And I'm also going to have there's a little bit of salt here which I'm going to wash off into the flask, but I'm going to measure out 100 grams of water. So let's go ahead and use this. I'm going to dry this. So I'll zero the mass of the beaker. Again, I'm not sure how close I'll get to 100, but we'll see. Okay, I'm just going to add a little bit here. Okay, that's very close. So 100.00 grams of water. And I'm going to wash off this little bit of salt here. So when you lose that. So this is good. Now let's transfer this. So there is my salt water mixture, which should dissolve, and this amounts to roughly 1 molarity concentration, but you're going to be calculating it more precisely, and the units we're going to use is molality. So you're going to calculate moles of NaCl that I just massed out, and then you will be dividing it by kilograms of water. So we measured mass of water in grams, converted to kilogram. Mole of the salt divided by kilogram of the solvent. That would be molality of this solution right here. So my solution is ready. And now I changed the the beaker to a styrofoam cup, mainly because it does a much better job insulating. And with the beaker I was getting a temperature of 9 degrees, and for the solution I need a colder temperature. By just changing the container, I'm down to like -11, close to -12 degrees Celsius. That's what I want. So let's go ahead and now do the same experiment with 8 milliliters of the solution. So let's go ahead and pour that in. Alright, this is good. Right on 8. So I haven't collected any data yet. So let's go ahead and insert this. We want this to be in the center. And I want to get the mixing going. So I just want to make sure that my stirrer works at this elevation. So it should work. Even at high elevation from the plate, it's still mixing pretty well. So this works. So it's going to actually be lower than that. And I'm going to increase the height, put this in. I have some big piece of ice in there which fell, I think, which is good. And the temperature of the bath is -11, which is pretty good. Okay, now I want to melt this and show you what happens again. So let's go ahead and remove this. You can actually see what's happened here. I'll put my ice water mixture here. See, this is frozen very solidly. Even the stirrer cannot move. So let me go ahead and melt this. So you see temperature is -3.7. You see the stirrer is starting to want to move. So there it is. Okay, so now you are watching the melting process. So we are collecting the data, and we're going to be looking at melting anyway. So you can see that there is ice floating, the mixture is turning, the temperature is rising. So the bath temperature, I'm not having the bath, so I shouldn't say that, but the temperature of the solution is at -1.4, which indicates that it's really melted. Everything is pretty melted there. So I'm going to now put this and freeze this again. So let's go ahead and expand our axis so you can see what's going on. Okay, now you can see the graph a little better. So I'm going to now raise this and put it inside of the ice bath again. It's sort of like repeating the experiment. The stir bar is moving, which is good. I want it to be mixed. Now watch these temperatures pretty closely and see what's going on. So the temperature of the solution is dropping, and it's reached the bath temperature, so I'm going to make my bath a little bit colder. I still see there's no freezing yet. Remember, this should be really freezing at a temperature of -3 something, so it's not frozen yet. And I can see there's still liquid in here. So I want to show you this really quickly. So even though the temperature is 9.8, watch, this thing is still not frozen. There's still liquid in there. It's totally liquid. It's not frozen yet. So when this is the nucleation process again that's happening. So I want to keep my stirrer going. The stirrer has to be going. Okay, now watch this thing rising. This is the beginning of the frozen part. I'm going to take this off so I can show you. Look, it's turned milky. So I'm going to put it back in because I need it to stay cold. But this is the freezing effect right here. You just saw the freezing effect. So temperature is rising, and it's going to stabilize. So there it is, -3.9. That's the same temperature, pretty close to it, since we had last time. But it is going to become constant. So this is the nucleation process. It's right by the thermometer. Let's put it here. Okay, now I have a better view. So this is where the nucleation took place, right down here. And now the temperature of freezing is stabilizing right here. So -3.8 is my temperature. Now at this point I'm going to, because you've already seen what's happened here in the process, so I'm going to take this off because now we don't need the ice bath anymore. So now watch my temperature here. So -3.9. So you can see that. Let's see if I can make this stirrer turn. See, the stirrer is frozen now. It has a hard time turning. There's like slush in the lower portion of the test tube. So I'm going to melt this a little bit because we want to see, even though it's outside in room temperature, the temperature is still -4 degrees Celsius. So I'm going to get the stirrer going. It's trying to get loose. I'm going to warm it with my hand. The temperature is starting to rise, -3.7. So we are now working on the melting process. We're looking at the melting. There it is. So everything is moving. Temperature is rising, -2.9. So we're watching the melting now. There was a big chunk of ice in there. I'm going to let that melt. Less ice, as you see. Temperature is -2.9 Celsius. Okay, there's just one piece of ice in there. It's almost melting completely. So once that ice piece is melted, you'll see a more rapid rise in temperature. Right here. Okay, so liquid now. So we are done with sodium chloride data. And again, I will forward you the data file for the experiment, time versus temperature, so you can graph it yourself and you can analyze it and pick the zone of interest for our determination. Okay, that's it. We're good for this run.